The learning objectives for this lesson are to describe and graph the sine, cosine and tangent functions, and describe and graph some other trigonometric functions. Graphing trigonometric functions. Trigonometric functions can be graphed on the coordinate plane. Graphs of periodic functions have repeating patterns or cycles. The horizontal length of each cycle is the period. One example of wave functions is visible light. Visible light waves have different wavelengths or periods. Red is the longest wavelength and violet has the shortest wavelength. The amplitude of a graph of a sine or cosine function equals half the difference between the maximum and minimum values of the function. First of all, we have the function y equals sine theta. Starts from 0, goes up to +1, down to -1, and back up to 0 in 360 degrees. Therefore, the period is 360 degrees, and the amplitude is 1, +1 and -1, which makes the range between y values between -1 and +1, and the domain is all of the real numbers, in this case, values of the angle theta. Y equals cos theta, on the other hand, starts from +1, goes down to -1, and back up to +1 at 360 degrees. However, all of the properties will be the same as the sine function. Period is 360 degrees, amplitude is 1, range is -1 to +1, and again, all real numbers or values of theta is the domain of the function. Let's look at an example. As with other functions, trigonometric functions can be transformed. For the graphs of y equals a sine b theta and y equals a cos b theta, the variables a and b are the amplitude and the period. Find the amplitude and period of y equals 4 cos 3 theta. The solution will be the amplitude is the absolute value of a. In this case, a is 4. The absolute value of 4 is 4. The period will be 360 degrees divided by the absolute value of b. 360 degrees over the absolute value of 3 in this example is 120 degrees. So the graph of the function will look like this. Y equals 4 cos 3 theta. Period will be 120 degrees with an amplitude of 4, so +4 to -4. It's a cos function, so it starts from the value of 4 at the top, goes down to -4, and back up to +4 every 120 degrees. Now let's look at some practice problems. Find the amplitude and period of each function. Y equals -1/2 cos theta and y equals 3 sine 5 theta. You can pause the video now and attempt these questions. We'll be back shortly to look at the solutions. Solution for A, the amplitude is the absolute value of -1/2, which is 1/2. The period is 360 degrees divided by the absolute value of 1, so that's 1 theta, which will be 360 degrees. For the second example, we have y equals 3 sine 5 theta. A is 3, the absolute value of 3, of course, is 3. and the period is, in this case, is 360 degrees divided by the absolute value of 5, because b is 5, and 360 divided by 5 is 72 degrees.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
Now let's use the graphs of parent functions to graph y equals a sine b theta and y equals a cos b theta. Then use the amplitude and period to draw the required sine and cosine curves. You can also use the theta intercepts to help you graph the functions. The theta intercepts of y equals a sine b theta and y equals a cos b theta in one cycle are as follows. For y equals a sine b theta, we have 0, 0, 1/2 times 360 degrees over b, 0, and 360 degrees over b, 0. For the function y equals a cos b theta, we have 1/4 times 360 degrees over b, 0, and 3/4 times 360 degrees over b, 0. Let's take a look now how this works in practice by using an example. Graph the function y equals 2 sine theta. First of all, we can look for the amplitude. So 2 is the value of a, absolute value of 2 is 2. Sine of theta, so that's 1 theta, 360 degrees divided by 1. The period is 360 degrees. The theta intercepts will be 0, 0, 1/2 times 360 degrees, which is 180 degrees, and 360 degrees divided by 1, which is 360 degrees. So for the graph, we will start from 0, 0. The amplitude is 2, so the graph goes up to 2, down to -2, and back to 0 again. The theta intercepts are 0, 0, 180, 0, and 360 degrees and 0. Now it's time for you to practice these concepts. Graph the function y equals cos 4 theta. Pause the video and challenge yourself to see if you can draw this graph, and we'll return shortly with the answer. Okay, so for the solution, this time the a, or value in front of the cos function, is 1, so the amplitude is 1. The period will be 360 degrees divided by the absolute value of 4, which is 90 degrees. The cos function starts at the point 0, 1. The next intercept will be 1/4 times 360 degrees over 4, 22.5 degrees, and 3/4 times 360 degrees divided by 4, which is 67.5 degrees, and 0. So the graph of the function will look like this. We'll start from +1, go down to -1, and +1, -1, with the period returning every 90 degrees. So 90 degrees there, and there, and there. And the values here, the intercepts where it crosses over the x-axis, are at multiples of 22.5 degrees and 67.5 degrees at this point here. Trigonometric functions are useful for modelling real-world periodic motion, such as sound waves. Often these waves are described in terms of their frequency. Frequency is the number of cycles in a given unit of time. The frequency of the graph is the reciprocal of the period of the function. So if the period of a function is 1 over 100 seconds, then the frequency is 100 cycles per second, or 100 hertz. The example given here is talking about sound waves for low frequency, normal range of hearing, and then the ultrasonic range goes from hertz to kilohertz up to megahertz, or millions of cycles per second. Let's look at an example. Sound that has a frequency below the human range is known as infrasound. Elephants can hear sound in the infrasound range with frequencies as low as 5 Hz or 5 cycles per second. Part A, find the period of the function that models the sound waves. If the frequency is 5 cycles per second, then the period is the reciprocal 1 over 5 or 0.2 seconds. B, write a sine function to represent the sound wave y as a function of time t. Let the amplitude equal 1 unit. So in this case, A equals 1. The period, we're going to use radians here, is 2 pi divided by the absolute value of B equals 0.2. Rearranging the equation, we get a value of B equals 10 pi. Substituting this into the equation, y equals a sine b theta equals sine 10 pi times t, which will give us this graph of the function to the right here, sine starting at 0, going up to +1, -1, and having a period of 0.2 seconds and 0.4 and so on. The tangent function is a trigonometric function whose graphs have asymptotes. The parent function, y equals tan theta, has a period of 180 degrees, not 360 degrees, like sine and cos. It has the range of all real numbers, or theta values. Its amplitude, though, is undefined as the graph goes from a plus infinity to a minus infinity value. So it has no amplitude, and the intercepts are given by these 3 equations here. For the graph of y equals tan b theta, there is no amplitude, and the period, like before, is 180 degrees divided by the absolute value of b. Let's take a look at an example. Find the period of y equals tan 2 theta, then graph the function. The period will be 180 degrees divided by the absolute value of 2, as we have in the function here, a tan b theta, and 180 degrees divided by 2 is 90 degrees. The asymptotes will be 180 degrees divided by 2 times the absolute value of b, which in this case is 4, so the asymptotes will be every 45 degrees. If you want to sketch the asymptotes, then that will start at -45, +45, and add another 90 degrees will get you to 135 degrees, and so on. So the graph of the function, y equals tan 2 theta, starting from -45 degrees with 1 cycle every 90 degrees, just like the graph on the right. For practice, try the following problem. Find the period of y equals 1/2 tan theta, then graph the function. Pause the video and make an attempt at this graph, and we will be back shortly to take a look at the answer. Okay, so in this case, the period is 180 degrees divided by the absolute value of 1. Remember that for A equals half tan 1 theta, then the value of B is going to be 1, so that's 180 degrees. The asymptotes are at 180 degrees times 2 times the absolute value of B, which is 90 degrees. Asymptotes are at minus 90 degrees, plus 90, add 180 onto 90 gets 270, and so on. Graph the function of y equals 1/2 tan theta. So start from minus 90 degrees, and there is one cycle every 180 degrees. In this case, I've used GeoGebra to graph the function. We have y equals 1/2 tan theta, starting at minus 90 degrees, starting from the bottom and going up to the top here, passing through 0, 0. The next value or asymptote will be 90 degrees and 270 degrees, and so on.